Hey everyone, thanks for tuning in. So today I'd like to talk to you about the Level Design 2 course outline revisions that I did as the final project for technology in the curriculum. This is one of my favorite courses in game development in that it's team-based and it's problem-based learning as well. What was a challenge with the course initially wasn't necessarily the technology that was already embedded in the course. It was more a situation of how to best communicate in the course. So the project-based learning exercise is a team-based approach where they have to recreate a historical environment in 14 weeks from its initial concepts and research right through to the finished environment. So this is one that was done a couple of years ago. It's 1930s New York, and that's the Ironworks building on the end. And you can see they've taken some liberties if you're aware of the location, but by and large, they researched the area, the cars of the time, the building materials in New York. And they even gave it like a sepia overtone to kind of set a mood of an older New York. So in this project, the students are divided up into teams. So there are teams of 4 plus me makes 5, and I, as my role as a teacher, I moved from being a teacher or an instructor to more of a mentor and a guide for each of the teams. The teams are created not necessarily by friends who all want to work together, but by job roles. So by this point in the semester, and you need to understand that this course is offered in the second half of the second year of a 3-year advanced diploma course, advanced diploma program. They've already started considering what kind of job roles they'd like to perform when they leave here and get their first job in industry. So there is no single leader. No one owns the project. People will step into leadership roles, though, as they move through the pipeline of production, and their particular skill set is in heavier demand for the project. So, for example, if we're into a heavy modeling cycle, your modeler will step forward a little bit and lead the others in modeling, and then maybe the environment artist later will step forward when it comes to lighting and post-processing and building out and arranging the location. So that means we have a big project. That big project is 14 weeks and is one really large project, which can be intimidating. So much so, in fact, that we found when we initially offered this kind of project, students would stagger and fall in the beginning and waste a lot of precious time just being overwhelmed with the size and scope of what they had to build with. And unfortunately, that is the nature of the beast. In this industry, you are always working on large-scale projects, so it's something that they need to become accustomed to. Our solution for that, and to get them to move forward more quickly and more easily and more confidently, was to introduce Scrum into the development process. So Scrum is basically a way to describe iterative design. And here in this diagram, you can see that we have a product backlog, which is basically what's left to do before the project is done when we get to the deliverable part on the end. A sprint backlog is what we'll see in the next sprint moving forward. And then you have 24-hour cycles in this diagram and sprints of 2 to 4 weeks. But we use a slightly more basic version of this. So what we do is we use what we call weeklies. And weeklies are builds that happen once a week. That just happens to fall academically in the course time that they have in the lab each week. And by that point in time, they have to have a buildable version of their exercise. So each scrum or each sprint that they're moving through has desired milestones and goals. And then they hit major gates when they've finished pre-production, when they've finished asset development, and when they're finally delivering the final product. So when you divide it up into these smaller steps, these smaller sprints, it suddenly becomes so much easier to handle because it isn't overwhelming anymore, and they can reach those deliverables more easily. And of course, once we have that, we realize that Scrum makes us all happy, just like these people right here. Anyway, so working remotely then is a big portion of this course that we hadn't addressed, and it's probably the biggest change that I instigated in in the course curriculum. Now, this is based on some work that we've already done in research with an external client doing a project for them for a mobile game, and we took some of the things we learned from that research and I've applied them here in the course curricula. So here we find that the students don't tend to work as much in the labs. They want to talk in the labs. They want to exchange information in the labs. They want to come to me as an instructor in the lab to solve some of their problems. So we've flipped the classroom, and I'm going to get to that in a moment. And so what I'm doing in the lab now is I'm providing ahead of time tutorials for covering some of the key technical or design procedures or techniques that we'll be using, so that they can view that in advance, and then when they come to the lab they can ask me specific questions about that content that they need to finish their product. That means that we can spend that 3 hours in class time working together to work as peers, exchanging information back and forth, or they can come to me and I can help them with specific problems, and their course time is used far more productively. So working remotely was a hodgepodge of different bits and pieces. We had our CMS system at the college, Blackboard, that we were using, but it was kind of clunky and not easy to use. And we put together a series of products that are free and that the students can connect to remotely from home or the school, and they can even have access to most of it directly on their mobile device, whether it's a phone or a tablet. So some of those tools that we're using now in the project and that I've put into the curricula include working with Padlet, which is something we've played with in our class before, and it's great for brainstorming. Everybody can log in at the same time, and synchronously they can start throwing up ideas and pinning it to a board, which it's going to record and hold later. And then you can take all those different elements, you can move them around the screen and group them so that they can clump their ideas. And this allows them to work collaboratively together, mashing ideas and bouncing ideas off each other, and then working with the ideas that they're seeing on the board to create new perspectives and new ideas just by working as a group. And that's been very, very effective. It's something that we're going to implement in other classes as well. From there, we started working with Slack, which is an awesome tool for communication. It's similar to other chat clients, but it borrows from the early days of IRC, and it allows your internet relay chat, and it allows you to create groups. It allows you to create channels for those groups so that you can have private channels and public channels, and you can divide those channels up into however you like to work. So on the project we were on, we divided channels up into job roles. So we had the modelers channel, and we had an environment channel, we had our programmers channel, we had our level designer channel, we had concept art as a channel, we had communication with a client as a channel, and certain people can get into those different channels. You can administrate who has access to those channels. So for example, directors and the client can be in one channel that the other members of the team wouldn't have access to, and then maybe we have a public channel that everybody in the group has access to for sharing information. So it's a great online tool, one we haven't covered in class, but definitely somebody should look at because we found it monumentally helpful for communication within a group or a team. The next piece is Trello, which I've talked about in class before, and I did my first project on Trello. Trello is great for project management, so they can get in together and organize content, whether it's in Google Drive or ideas cards, and we can visually diagram the Scrum cycle and our Scrum backlog and our product backlog, and everybody can see who's working on what when, what the deliverables are in time moving forward, what the due dates are on that. We can even generate Gantt charts complete with dependencies based on dates on cards in Trello. So the task is very automated. It's available on a mobile device, so anyone can check in, maintain at a glance, and all notifications from Trello and Slack for that matter are all pushed to the mobile device. So at the moment change happens, if you're subscribed to those channels or those cards, that information is pushed directly to your phone. So we have instant feedback and instant communication. The files themselves are hosted on cards in Trello, but we have to have a place to put them. And for lack of a better storage space right now, we've moved to Google Drive. Google Drive seems to be the easiest for everyone. Most people have a Google account. Gives us access to the Google apps as well, like Docs, Sheets, and Slides, which allows for concurrent development amongst members of a team. It's also extremely good for things like living documents that they'll work with and manage inside their teams. So it's a good all-in-one set of apps and storage tools for them to share source files and stuff back and forth as they're developing content. We work with Bitbucket as a cloud project repository. So as a repository, what they're doing is, while they have different assets they might be building, like pictures, textures, models, not all of those would go into the final project file. They get imported into the final project file, but the final project file is the build, the thing that would be delivered at the end. What we like to do is use Bitbucket as a cloud repository, because Bitbucket allows you to do versioning control on your files, or version control on your files, and it does rollback. So every time you commit changes from your project, and each person can do this remotely from their own computer at home or at school, every time a commit is pushed, the rollback is stored so that if something gets corrupted or something needs to be rolled back, you can just click and pull down an older version, and it resets your file to an older previous version. It supports branching and forking and a number of other tools for content management. It's an excellent resource, limited storage capacity, but in our particular case, that works very well for us because it keeps the students under budget. To manage the Bitbucket accounts, we're using SourceTree. SourceTree is a visual front end for Bitbucket, which allows them to manage their files on their computer. If they decide that they're working in the lab, all they have to do is commit and push in the lab before they turn off their machines, go home, hit pull, and it pulls down all the latest changes. It's an incremental backup system, so it's not going to pull down the whole set of files every time, which is good. It only brings down the changes, which is excellent. So we're finding that as a front end. It works on Mac PC. Great for the students as well, because they don't have to carry the project files around with them anymore. They just need an internet connection, and for a full commit, a little bit of time. For partial updates, next to no time at all before they're updated and moving forward. So with all this in mind, as I mentioned before, we're flipping the classroom, and this is giving us the opportunity to use time the way time would probably normally be spent in an office, where in an office situation or in a professional studio environment, you're working during the day, sure, but you're using that time at the office or in the studio to be checking in with other people, to have meetings about different ideas, to work together, communicate with each other, exchange information, and get sign off and revision done. But the online component for us allows them to do a lot of the work outside of that small meeting time that we have. So similar to work, where you'd only have a short amount of time for actual meetings and you'd spend your time away from that meeting time doing the actual work, that's what we're doing in the classroom now. So when they're working remotely at home, it's empowering them to be a member of a real studio team. In this simulation, we're not sugarcoating things, we're not dumbing anything down, we're actually using the same workflow we used with our clients. And that empowers them to contribute as a member of a team, to get work done and be responsible for the deadlines, and it allows them to use their class time to meet as a group in person to deal with the things that we need to deal with there, and get one-on-one time with their professor, which is incredibly hard to get sometimes in an academic environment. So that's the little bits and pieces in a nutshell, and I hope it covers it. Please spend a little bit of time reading the supplementary content that I've provided with the course outline. I'm really excited about this. I actually spent a lot more time putting this together than I thought I would originally, just because in being quote unquote forced to commit these ideas to paper, it really let me solidify some of the goals and objectives that have been covered in the class, and allowed me to be productive with that information to come up with something that's going to be useful and meaningful for my students in the future. So thanks for watching, and have a great day.